Hello students, welcome back to our ongoing journey through the 12th grade physics animation series. Today, we are going to dive into the concept of electrical capacitance of conductors. But what exactly is capacitance? Let's begin with this question. The electrical capacitance of a conductor refers to its ability to hold electric charge. But wait, I said ability, which cannot be infinite. So how much charge can a conductor actually hold and for how long? To understand this, let's imagine a spherical conductor and somehow give it a positive charge. We have already learned in this video that as the number of charges within a conductor increases, the electric field intensity and potential of the conductor also increases. This implies that the power to not allow a new positive charge into a conductor is also increasing. Or to put it another way, the power to attract a negative charge is also increasing. Now, there is air surrounding this conductor acting as insulation, preventing charges from escaping the conductor. But as soon as we introduce more charges into the conductor, its potential energy starts to increase. Eventually, a point will come where the conductor will attract electrons from the atom of the air to reach a stable state and neutralize the extra charge. This process results in a positive charge on the air atom and neutralization of an extra charge on the conductor. Alternatively, you could say that a positive charge has been transferred from the conductor to the molecule of air, meaning that charge has leaked. This process of breakdown of air atoms is known as the ionization of air, and the ability of air to withstand the electric field without ionizing is termed as the dielectric strength of air, which is numerically equal to 3 into 10 to the power 6 volts per meter, and dielectric refers to an insulator. So, by considering all other possible factors constant, the amount of charges a conductor can hold depends on the dielectric strength of the insulating material surrounding it. If the dielectric strength is higher, the conductor's ability to hold charges will also be higher, meaning its capacitance will be greater. Simply, high dielectric strength means ionization of insulation will be difficult. Therefore, more charges can be stored in a conductor. In the upcoming videos, we will dive into a detailed explanation of dielectric. So, we observed that when we increase the charge Q, the potential V of the conductor also increases, meaning Q and V are directly proportional to each other. Removing the sign of proportionality gives us a constant C, which is called the capacitance of the conductor, and C equals Q divided by V. Now, if we understand capacitance numerically, the capacitance of a conductor can be defined as the amount of charges required to increase the potential of the conductor by 1 volt. Capacitance, denoted by C, is a scalar quantity measured in farads. Now, at last, let's understand 1 farad of capacitance. We have just seen that capacitance C can be written as Q divided by V. So, 1 farad of capacitance for a conductor is achieved when increasing the potential by 1 volt requires 1 coulombs of charge. You can think of 1 farad of capacitance simply as 1 coulomb per volt. This was the 21st video in the 12th grade physics animation series. To watch the rest of the videos in this series, check out the playlist and join us on the visual journey through 12th grade physics. Thank you so much for watching this video.